Okay, so now we're going to start the third set, questions 21 through questions 30. And we're looking at 21. I'll get a pen here. Question 21. It reads, solve the following logarithmic equation, and we have 2 times, I'll turn on the light here. Better without the light. 2 times the natural log of x minus 1 is equal to the natural log of x plus 2 plus the natural log of 4. Okay, so let me just double check. 2 times the natural log of x minus 1 equals the natural log of x plus 2 plus the natural log of 4. So the logarithmic properties apply both to the natural log and to the common log. So we're going to apply the product property that allows us to combine the sum of 2 logarithms into one by multiplying the arguments. So we have x plus 2 times 4. So natural log of x plus 2 times 4. And here on the left side, we have 2 times the natural log of x minus 1. And now we're going to go ahead and distribute the 4. We're going to multiply x times 4 and 2 times 4 to give us the natural log of 4x plus 8. And here we have 2 times the natural log of x minus 1. Now, here what we can do is, since we need to combine the logarithms that have x as the argument, we're going to have to distribute. So what we're going to do is, yes, we're going to have to distribute. Actually, what we're going to do here, I see. Now we have applying the logarithmic properties. We can do something here to move back to 2, where as an exponent, if you recall the power property, the log of base a x to the r is equal to r times the log base a, the log of x base a. So applying the power property, we can write natural log of x minus 1 squared equals the natural log of 4x plus 8. Now, there's a property that allows us to get rid of the logarithms at this point, because remember the property that says if I have the log of x equal to the log of y, so if we have this 2 logs are equal, they have the different arguments, then it must be that the arguments are equal. So applying that property, we can say, well, x minus 1 squared is equal to 4x plus 8. Okay. And now this becomes an easier problem, because x minus 1 squared, we write x minus 1 times x minus 1 equals 4x plus 8. And we're going to FOIL, so we are going to multiply x times x, and then x times negative 1, negative 1 times x, and negative 1 times negative 1. So that gives us x squared minus x plus 1 equals 4x plus 8. And then we combine the like terms, so minus x gives us minus 2x plus 1 equals 4x plus 8. And we want to set this quadratic equation equal to 0, so you can subtract 4x and 8 from both sides. I'm going to do it at the same time to save time. And that's going to give us x squared minus 6x minus 2x minus 4x is minus 6x minus 7 equal to 0, because the 4x cancels with the negative 4x. The positive 8 cancels with the negative 8. And so we have x squared minus 6x minus 7 equals 0, which we can factor to give us x times x minus 7 plus 1 gives us the negative 7, right? So we look for 2 numbers that multiply to negative 7 and add up to negative 1. That would be negative 7 and 1. When we apply the zero factor property, we can apply the zero factor property and set each factor equal to 0 to give us, as a solution, we get x equals 7, x equals -1. We need to check each one because remember that the argument of a logarithm cannot be negative. So we need to go back to the original. So keep an eye on the solution 7 and -1. So I'm going to x equals 7 and x equals -1 and see if these work. So we see that 7 would not be a problem if you plug it back into the argument. 7 minus 1 is positive, 7 plus 2. However, the -1 plugged into this argument here will give us -2, so that would not work. So the only solution is going to be 7. So the solution is 7. Make sure you check the solutions back into the original logarithmic equation to satisfy the condition that the argument has to be positive. Okay, so the answer there is 7 for 21. And let me move the paper down so you can see everything there. And then back up. And then to the side. Okay, let's move on to 22. And let me share my screen here because sometimes I forget. I say, let's move on to the next question and I'm not sharing my screen. All right, so there it is. I'm sharing number 22. And we're solving the exponential equation. And we have an exponential equation for 22. 4 raised to the -8x equals 64. And for this type of problem, yes, it's 4 to the -8x equals 64. And for this type of problem, let me go back here to Zoom. We want to rewrite the bases. So that I can apply a property. So we're going to be using this property that if I have a base a raised to the x, and that's equal to a base a raised to the y, then x must be equal to y. So I want to apply this property, but to do that, I have to rewrite the 4 and the 64 so that they have the same base. So I can find the prime factors, 2 times 2. So then 4 is 2 to the second power. And then 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. So we count the 2's, 1, 2, 3, 4, 5, 6. So that's 2 to the 6th power. So we can rewrite the 4 as 2 to the second. And then, of course, we need to raise that to the -8x. And then the 64 to the 2 to the 6th power. And then applying the rule that when you have a base raised to the x raised to another power, you multiply those powers, right? That's a raised to the x times y. So we're going to multiply the powers here. So that's going to be 2 to the -16x, right? 2 times -8x is -16x equals 2 to the 6th. Now that I have the same base, I can set the exponents equal. -16x equals 6. And then I can divide by -16 both sides. That's gonna get rid of the -16s on the left side, right? And so we have x equals a -6/16, which can reduce to -3/8. So that would be the answer, -3/8 for number 22. Okay. And now, let's see. We can, in just a second. So that would be 22, yes. Now let's move on to question number 23. So question 23 is another exponential equation. But that one, as you can see, we really cannot rewrite so that we can get the same base. It's the 4 and the 5 will not have any common factors. And so let me write down, it's 4 raised to the x plus 2 is equal to 5 raised to the x minus 6. And looking at this one, we want to observe the bases. The bases here are not comparable. And even if you find the factors, so 5 is prime, so 4 is composite, so they will not, if you break the 4 into prime factors, you only get 2 times 2, and this one 1 times 5. So actually 1 is not prime, so you wouldn't be able to. So we see that that's really to no avail. So the only thing we can do is turn this exponential equation into a logarithmic equation. So I'm going to take the natural log or the common log of 4 raised to the x plus 2 equal to the natural log of 5 raised to the x minus 6. And applying the logarithmic properties, the power property, we will bring down the exponent x plus 2, and I'm going to write it in parentheses because it's going to be x plus 2 times the natural log of 4 equals x minus 6 in parentheses times the natural log of 5. Okay, now over here, the only thing we can do here is distribute because we're trying to get the logarithms that have x as part of them. We want to get those on this one side, and those logarithms that don't have any x in them, we want to get them on the other side. So what we can do is distribute, and so we multiply x times the natural log of 4. Remember, this is together natural log of 4, and then 2 times the natural log of 4. So that's going to give us x times the natural log of 4. So x times the natural log of 4 plus 2 times the natural log of 4, right? And you're going to do the same thing here. So it's going to be x times the natural log of 5, and then minus 6 times the natural log of 5. So x times natural log of 5 minus 6 times natural log of 5. All right, now, those logarithms that have x next to them, we want to combine them. So what I'm going to do is I'm going to subtract minus x times natural log of 5 to move the x times natural log of 5 to the left. So minus x times natural log of 5. And so on the left side, we're going to have x times the natural log of 4 minus x times the natural log of 5. Don't forget the plus 2 times the natural log of 4 equals, and then remember that on the right side, these are going to cancel. X times the natural log of 5 cancels with minus the natural log of 5. And so now we have, when these two cancel, you get negative 6 times the natural log of 5. Okay. So I'm displaying the whole thing there. Now, when you're here, you want to move the 2 times the natural log of 4 to the right because that one doesn't have an x. So we are going to subtract minus 2 times the natural log of 4 minus 2 times the natural log of 4 from both sides. And, excuse me. And now we're going to, so this is going to cancel the 2 times the natural log of 4. And so we get x times natural log of 4 minus x times natural log of 5 equals minus 6 times natural log of 5 minus 2 times natural log of 4, right? And so now we can factor out the x because remember you're trying to solve for x. So factor out the x out, and this is times natural log of 4 minus natural log of 5, right? So you factor out the x and you're left with natural log of 4 minus natural log of 5 in parentheses equals negative 6 times natural log of 5 minus 2 times natural log of 4, okay? And now, and I have room here, so I'm going to continue working here at the top. Notice what you have, but write it down because we're going to continue. So now we're going to divide both sides by, notice what we're going to do. We're going to divide to get rid of the natural log of 4 minus natural log of 5. We will divide by the natural log of 4 minus natural log of 5, both sides. Divide that by natural log of 4 minus natural log of 5, right? Divide by that. You can put it in parentheses or you don't have, I mean, if you want to, but it's a big parentheses there. You don't really have to, but just so you know, it's the whole expression, right? So this on the left side, this is going to cancel, right? That's going to cancel. And so you're left with, I'm going to move the paper a little bit here so I'm going to write here what we are left with. So x is equal to -6 times natural log of 5 minus 2 times natural log of 4. All that divided by the natural log of 4 minus the natural log of 5, which now you can use your calculator and find the answer, right? So once again, let me lower the paper so you can see everything to the side. I'm writing everything to the side here so you can see. And then down. And then let's go back to where we are now. And with your calculator, you can see, so fraction, and then we've got -6 times the natural log of 5 minus 2 times the natural log of 4. And then you're going to divide that by the natural log of 4 minus the natural log of 5, which will give us 55.7005391, and we will see how many digits we have to keep. Let's go back to the instructions we're going to read. So reading 23, it says, round all intermediate values to 6 decimal places as needed. Okay, this is what we need to know. Round the final answer to 3 decimal places as needed. So if it's going to be 3 decimal places, we want to keep, it's going to be 55. So 3 decimal places, 1, 2, 3. And so 0, it's going to be, 701, right? Because the 5 will change the 0 to a 1. So 55.701. So x is 55.701. Okay? That's the answer to question 23. And moving on to the next question, 24. Now we're going to look at question 24. It reads, a student received an inheritance from her grandmother of $3,000. And she places the money in a savings account, paying simple interest at 15%. What will be the value of the account after 3 months? So this is a simple interest question, and we're looking for future value, right? We know that the present value is the amount that we start with. So we want to write down some of the numbers here that we need. So we know it's a simple interest question. I'm going to just write down simple interest question so that I know which formulas I can look at. And the principal or the present value is $3,000. And the money is going to pay simple interest at 15%. So R is 15%. And we're looking at time of 3 months. And the question is, what will be the value of the account after 3 months? So the future value formula, when you're dealing with simple interest, is future value is equal to present value, parentheses, 1 plus R times T. Now the present value is $3,000. The interest rate, we need to write it in decimal form. So if it's 15%, remember, if you're going to convert to a decimal, you divide by 100. So that gives us 0.15, right? 15%, 0.15 in decimal form. So you just move it 2 places from the 5 here, 1, 2. So it will give us 0.15. So 0.15. And the time also you need to convert to a year. It's 3 months, but we must convert to 1 year. You divide it by the number of months in a year, which that gives us 3/12, which reduces to 1/4. And so you multiply by 1/4 here. And with your calculator, you plug in all this information. So 3,000, and then 1 plus 0.15 times 1/4. And then that gives us the future value, right? The 15%, let me see. Oh, you know, I put 5%, I apologize. So it's 3,000. 1 plus 0.15 times 1 over 4. And now that's going to give us 3,112 and 50 cents. 3,112 and 50 cents. 0.5 or 0.50. That's the future value. That's how much there will be in the account after 3 months. So that's a simple interest question, 2024. Okay, so let's go to 25 now. Question 25, it reads, tuition of 1,768 will be due when the spring term begins in 6 months. Okay. What amount should a student deposit today at 7.97% to have enough to pay the tuition? Notice that nowhere in the problem it's saying that there's compoundings of any sort, which tells us that this is another simple interest question, right? Because if you do not read anywhere in the problem the word compoundings or compounded, then that means you have usually that's a sign that you have a simple interest question, right? If you're working with these types of problems. So it doesn't have compounding anywhere. So we know that the future value is given because that's how much I have to pay in 6 months. So that's going to be future value. So that's 1,768. And I know it's a simple interest question because I don't see compounding anywhere. So I'm going to write down simple interest and then the future value amount. The time they are giving me is 6 months. What amount should a student deposit today? So they want the today value, so that's the present value. And the interest rate is 7.97%. So how much do we need to deposit today to have enough for this tuition? You can use the present value formula for simple interest, and that's present value equals future value divided by 1 plus R times T. And this is just, you can derive this from the previous formula. You know, you can derive this from the future value formula, which is PV. Remember the future value formula we had? And that's, let me see which one I gave you. So I want to make sure I give you the same one for 24. I gave you future value PV and then 1 plus R times T, right? So if you solve for PV, you get exactly this. That's how you can just find the present value formula, just solving for PV here in the future value formula. So future value is 1,768. And then you have 1 plus the interest rate. If I convert the interest rate to decimal, I get 0.0797, right? And 6 months, it's if you convert 6 months, we've got 6 over 12, right? 6 months divided by 12 months in a year, we get 1/2, okay? For T, for the time. And so we can write 1/2 here, and then go ahead and enter that into the calculator, and we should get the present value for what we need in order to have enough to pay for the tuition in 6 months. So entering all that in the calculator, and I think we need to round. So we get 1,700, 1,700 and some cents. Let's go ahead and read the rounding instructions. Make sure you read the rounding instructions carefully because sometimes you do everything right, but you forget to round. It says simplify, for 25, it says simplify your answer, round to the nearest dollar. So if I round to the nearest dollar here, I look at the cents figure here is 20 cents, 24 cents. So this is going to be $1,700. So I need to deposit almost everything today, right? almost everything today in order to have 1,768 in 6 months. I need to deposit $1,700 today. So it's almost the entire amount, right? Almost. Okay, so that's question 25. Moving on to question 26. And we have a person wants to invest $25,000 for 3 years and is considering two different investments. The first investment, so okay, so here we have two different types of investments. Let me I'm gonna do this because it's two different kinds of investments. I'm gonna have investment one, investment two. So okay, the first investment, so I'm gonna call this one, and this is question 26. The first investment one and investment two. Okay, so a person wants to invest 25,000. So I have the investment is 25,000. That's going to be the present value, 25,000 for both. And the time is 3 years. I'm just writing down the details. The first investment is a money market fund, pays a guaranteed 5.9%. So the interest rate for the first investment is 5.9%. And I have some compounding here. So obviously, this is no longer simple interest. We're dealing with compound interest. Compounded daily. So N is the number of compoundings. I'm going to use the letter N for that. And it's going to be daily. So let's use 365 days. And then the second investment is a treasury note that's going to pay 6.1%. Annual interest rate. So this one is compounded annually because it says it's annually. So one period, one year. And which investment pays the most interest over a 3-year period? Okay. So in order to answer this question, we want to figure out, since we know the present value, right? If we can figure out the future value, we can subtract the future value. We can subtract the present value from the future value in each case and figure out the interest for each. And then the one that pays the most interest, we can just say that that's the best investment, right? So this is compound interest. So this is compound interest. And the formula, so for both cases, we're going to have compound interest, right? And the formula for future value for compound interest is future value is equal to present value, parentheses, 1 plus R divided by N raised to the N times T. N is the number of compoundings in this problem. So the number of compoundings for the first case, we have 25,000 is the present value. The interest rate in decimal form is 0.059, compounded daily, so divided by 365. And then you're going to raise that to the N times T, so 365 times 3 because it's 3 years. So that's for the first case. For the second investment, we use the same formula, future value equals present value, 1 plus R divided by N raised to the N times T. Present value is still 25,000. The interest rate is 0.061 divided by 1 because it's paid once a year. And then 1 times 3. Remember, N here represents number of compoundings. N represents number of compoundings. Because I know in the annuity questions, we use different notation. But for this section, compound interest, let's say that N represents how many compoundings per year. Compoundings per year. Okay? All right, so remember they told us that for the second investment is 1 compounding per year, or it says it's paid at the end of the year once a year, so it's really 1 compounding. And for the first investment, it's compounded daily, so you've got 365 compounding. So now enter that into the calculator for each case, and we're going to figure out how much we will have in each account, and then we can figure out the interest. So be careful here when entering these numbers. 25,000, parentheses 1 plus, and then fraction 0.059 divided by 365. Close the parentheses and then raise that to 365 times 3. And that gives us 29,840. And let's round to cents, 35 cents. So that's the total amount, the future value. But remember, they're asking for interest. So that's for the first investment. This is how much there will be in the account after 3 years. Now let's figure out the same for investment 2. How much are we going to have in the account after 3 years? And we've got 25,000, parentheses 1 plus, fraction 0.061 divided by 1, raised to 1 times 3. And we've got 29,859 and 75 cents. Okay, now we're looking for the interest. So take this amount, 29,840 and 35 cents minus the 25,000. It's going to give us the interest for the first investment. So the interest for the first investment is equal to 4,840 and 35 cents. 4,840 and 840 and 35 cents. And the interest for the second investment you take the 29,859 and 75 cents and subtract the principal amount of 25,000, and we get 4,859 and 75 cents. So the investment 2, which is a treasury note, is a better investment because it pays more interest, right? The interest on the treasury note, because the treasury note is the treasury note is a second investment, right? So let's take a look here. Let me go back to the question. The treasury note is a second investment. Yes. So the second investment pays more interest because the second investment pays 4,859 and 75 cents versus the first investment pays us 4,840 and 35 cents. So we should go with the treasury note, right? That's question 26. Let's move on to 27. And 27 reads, a company will need 70,000 in 6 years for a new addition. Okay, so that is actually the future value, right? To meet this goal, the company deposits money in an account today that pays 10% annual interest compounded quarterly. So it's giving us the compoundings there. So let's write down the information. Find the amount that should be invested to total 70,000 in 6 years. So we've got question 27. We will need a future value of 70,000. And then we're going to open an account that's going to pay 10% compounded quarterly. So N, remember N is the number of compoundings. So compounded quarterly means 4 times in a year. Find the amount that should be invested. So find the present value, and we have 6 years to work with. So this is a compound interest question, and the formula we can use for compound interest. So this is compound interest. Formula for present value is future value divided by 1 plus R divided by N raised to the N times T. This is just deriving it from the future value formula. So we want to have 70,000 in 6 years. The interest rate is 10%, so 0.10 divided by 4, because we have compoundings are quarterly, so 4 times in a year, and we have 6 years. So we raise it to 4 times 6. Number of compoundings, n is 4. We have t is 6 years. So if you enter this in the calculator, we have 70,000, and then parentheses 1 plus 0.10 and divided by 4. We raise it to 4 times 6. And so we get 38,701.27. That's how much we should deposit today in order to have 70,000 in 6 years. So you see now, as we are dealing with with larger amounts, you can really see the power of compound interest, right? How in 6 years you can reach the goal of 70,000 because the amount that we deposit is pretty good. It's pretty, I mean, it's significant, right? It's 38,701.27. So that's a pretty decent amount that you deposit, you leave it there for 6 years, and interest is being paid quarterly, so every 3 months. And that gives us 4 payments in a year of interest, and then it compounds, so the interest is added to the principal after each payment. So then that is how the money grows fast. So you can really see the power of compound interest at work here, right? Okay, so that is question 27. Let's move on to question 28. And question 28 reads, if inflation has been running at 4.06% per year, and a new car costs 27,400 today, what would it have cost 3 years ago? Now, when you read this question, you need to read it very carefully, because when you read the word today, you may think that the 27,400 is referring to the present value. However, if you read more carefully, the question is asking for what would it have cost 3 years ago. So obviously the 27,400 is representing future value, not present. And so we're going to have to go back 3 years. And so what we have here really is the future value. So we can write down the information here for 28. We have the future value given to us as 27,400. And inflation, you can look at inflation as an interest rate because it's an increase in prices per year, right? So it's 4.06%. Be careful there, because when you convert, make sure that you count rightly the number of spaces to the left, so that's going to give us 0.0406, right? Now, and then we have the time is 3 years, and we're looking for the present value. And the present value that we're talking about here is 3 years ago. So what is the present value 3 years ago, right? I know it's an interesting question, the way it's worded, but okay. So again, you're looking at compound interest and you're looking for present value. So the present value is equal to future value, which is the cost of the car now, but remember, we're going back in time, 3 years. And then 1 plus r divided by n raised to the n times t. The future value is today's price, 27,400. 1 plus 0.0406. And then it's per year. Inflation is measured on a per year basis. So the compoundings is 1, the n is 1, because it's once, it's annually. So this is an annual measure. And then you raise that to the 1 times, you're looking at 3 years, so t is 3. And so when you enter this in the calculator, it's going to give us the present value or the price of the car 3 years ago. So 27,400. And then we've got 1 plus 0.0406 divided by 1. And I'm going to raise that to 1 times 3, or just 3. And that gives me the price of the car 3 years ago is 24,316.39. So that's how much the car cost. That was the price of the car 3 years ago, approximately. So 24,316.39. If we go with this inflation rate, okay. All right, now that is question number 28. So that we dealt with simple interest questions and then compound interest questions. And I think the next set of questions have to do with compound interest, but the case of the annuities, and we're going to talk about a little bit about annuities next. So question 29 reads, find the future value for the ordinary annuity with the given payment and interest rate. Okay, so let's write down the payment for the annuity. Remember, annuities are like savings accounts that you deposit money into for a long time, and you usually make fixed payments. And then at the end of when you're ready to retire or when you reach a certain age, they have some limitations as to when you can withdraw. You can start making withdrawals. And you are basically doing this because compound interest will make this account grow right over time. So it's an investment, a long-term investment that you want to do when you open up these types of accounts. So now let me go ahead and write down the information here for 28. Actually, it's 29. So the payment for the annuity PMT is 2,400, and the interest rate compounded, so R is 1.55%, and it is compounded monthly. So compounded monthly, and we want to have 5 years according to the problem. So this is going to be for 5 years, and we want to look for the future value of the ordinary annuity. So what we want to do is find the number of periods per year. Well, that is 12. And so the way to figure out the total number of periods is we're going to take the n, which is 12, right? And in order to figure out, in this case, the n is going to be 12, which is the number of periods per year, right? But then we're going to multiply that to the times the number of years. So our n is going to be 60 this time, right? So we take the number of periods per year, which is 12, times the number of years, gives me the total number of periods, which is 60. And the annual interest rate, which is 1.55%, since there are 12 periods, we have to figure out the interest rate. The way to calculate the I for this type of problem is you take the R, right, which is 0.0155, and you divide it by the number of periods per year. And that will give you your I for the annuity formula, which I'm going to write down here. So the annuity formula for the ordinary annuity that I'm going to be using is the payment times, and there are more than one, so that's why I'm saying for the one I'm going to be using. So 1 plus I, and then raised to the n minus 1, all that divided by I in a bracket or parentheses. And now you go ahead and write down, so the payment is going to be 2,400 times 1 plus the I, remember that's going to be 0.0155 divided by 12, raised to the n, which is 60. Don't forget the minus 1. Sometimes students forget the minus 1, and I'm guilty of that too. All that is going to be divided by the I, which is 0.0155 divided by 12, okay? So when we enter all that in the calculator, it's going to give us the future value of the ordinary annuity. And so let me get the calculator here. Be very careful when you're entering all this information. So we've got 2,400, and then parentheses, and then we have a fraction. And then within that, on the numerator, we're going to have parentheses again, and then 1 plus another fraction, 0.0155 down, divide that by 12. close the parentheses, and then raise it to the 60th power, and then bring down the cursor and then do -1, and then come down to the denominator, and then a fraction, and then we have 0.0155, divide that by 12, and then go and close the main parentheses. Don't forget to do that. And then we get 149,626 and 58 cents. 149,626 and 58 cents. And that is the answer to question 29 that was asking for the future value of the ordinary annuity. Remember, don't round until the final answer. The final answer, then you round it to the nearest cent as needed, okay? So that's question 29. And so if you use the right formula, trying to use a formula that is easy, so I picked the easiest formula there in the question, and I'm consistent with what MyLabs is using, so it's the same formula you're going to use in MyLabs when you do your homework questions. Okay, now let's go to question 30. And that's the last question for this third set of questions. So this set was shorter than the other two because the questions don't require so much work. You just need to have the right formulas. So set number 3, as you noticed, you will notice when you do this, it's shorter than the other two sets. First and second sets are much longer. Okay, so question 30 it reads, I'll find the amount of the payment made into a sinking fund so that enough will be present to accumulate the following amount. Payments are made at the end of each period. Okay, so we have a future value for number 30. The future value is 85,000. Because that is what we're trying to accumulate. And the compounded semi-annually, so the n in this case is going to be 2. So to get the interest rate, so the n, the total number of compoundings will be 2 times, and this is for how long? 1.5 years, so 2 times 1.5. That's going to give me 3, right? Because it's semi-annually, so that's 2 periods in a year, times the number of years is 1.5, so 1.5, so 1.5. So then the n will equal 2 times 1.5, n equals 2 times 1.5, which gives us 3, right? And then the I is going to be the interest rate in decimal form, 0.04, divided by the number of periods per year, which is 2, which will give us 0.02. So let me show you here what I have, right? And just verify that that makes sense. So 2 times 1.5, that is indeed 3. And then 0.04 divided by 2 gives us 0.02. Now the formula for the payment is going to be PMT equals future value times I divided by 1 plus I to the n minus 1. So go ahead and enter the information here. The future value is 85,000. And the I is 0.02 once I reduce. Divide that by 1 plus 0.02. And then that's going to be raised to the n, which is 3 minus 1. Right? And so enter that into the calculator and we get the fraction 85,000 and then times 0.02 divided by parentheses 1 plus 0.02 parentheses raised to the third power minus 1. So it's going to be 27,774 and 15 cents. Once I round to the final answer to the nearest cent, we get 27,774 and 15 cents. So that's question number 30. Let me erase the paper there so you can see that the top and then the bottom. The top again. and then the bottom. And then if we go to the question, let's take a look here. It says that round to the nearest cent. So that is why we're rounding to 15 cents. Okay, so that's question 30. Now, set number 4 will include questions 31 through 40. So that will come after. Thank you for watching, and I will stop recording now. See you on the next one. Take care.